So what you need to know for this is an exponential function, and it's usually in the form of y equals something b to the x. So if this b is greater than 1, right, then it's growth. Right, so it's a 3 here, so it's growth. So all exponential growth looks something like this, right? And I think the important thing here is the y-intercept. You can graph this by just plotting points. So you can say x, y, and then if you plug in a 0, you get something like 3 to the 0 minus 4, right? So then, yeah, anything to the 0 power is 1, so this is negative 3, right? So typically, this exponential function would go through 1, 0, comma 1, right? But that minus 4 drags it down 4. And minus 4 does a transformation down 4. So this is kind of what it would be. And I would say graphing it by points is like the best way to start this. Right, so you can plug in 0, comma negative 3. Right, so this is 0, comma negative 3. And then you can also plug in a 1. That's 3 to the 1 minus 4, which is 3 minus 4, which is negative 1. So it's 1, comma negative 1. So I kind of drew this bad. Let me erase. I can't erase. Okay. So yeah, it'll be 0, comma negative 3, 1, comma negative 1. And then if I plug in a 2, I get 3 squared minus 4, which is 9 minus 4, which is 5. So I get 2, comma 5. 2, comma 1, 2, 3, 4, 5. Yeah. And then if I go backwards, right, if I plug in a negative 1, I get 3 to the negative 1 minus 4. Remember, 3 to the negative 1 is 1 over 3. 1 over 3 minus 4, this is negative 3 and 2/3. Right, so it's negative 1, comma, negative 1, 2, 3 and 2/3, like right there. Right, so we end up getting a more accurate graph by putting dots. If I want the third thing, I could plug in a 3, I guess. If I plug in a 3, it's 3 to the third minus 4. 3 to the third is 27. 27 minus 4 is 23. That goes off the graph, literally. So something like that. Okay, so that's how you would graph it, using a table of values, right? And then if you want to find the domain, remember, this is all the inputs, all the possible x values, and you can plug in anything. This goes to infinity, so to the left and up. So this is all real numbers, right? And then the range is going to be, there's something called the asymptote here, meaning it never touches. It never touches, what color? I'll do this color. It never touches this, right? And that is y equals negative 4, right? It never touches that, so it can never hit y equals negative 4. So it's everything bigger than y equals negative 4. So that's the range. The y-intercept is when x is 0. I should write that. So this is when x equals 0. And we know that, yeah, it's 0, comma negative 3. Right, and then the asymptote is y equals negative 4. Right, that's this green imaginary line that it never touches. Okay, so that's the answers. And you kind of want to think of this in terms, like when you graph it, it's good to plug in numbers and then see what dots you get. But when you think of this, you should think of it in terms of every single exponential graph. Every single exponential graph looks something like this, right, for growth. Right, if this b is greater than 1 and it's a growth, it'll look something like this, where it never touches the x-axis, and it almost always goes through 0, comma 1. Right, this is a standard parent function. Oops. Yeah, it's a standard parent function. I don't know how to get rid of this. Okay.